Okay, so that's the conservation of energy in mathematical terms. A more difficult statement is actually that these two are equivalent. If you have a vector field such that the energy is conserved, then it must be a gradient of something. And we are not ready yet to understand why. Because to understand why, you really have to study something. Vector fields. And that basically suggests a plan for the future. Study vector fields. And naturally you study all vector fields. But we know how to study all things in calculus. Okay? So we think about all possible vector fields. All vector fields. And among all the vector fields, we study first very special fields. So we study linear vector fields. And we don't know yet what it means to be linear. But it's relatively easy to guess if you think about a vector field algebraically. Because geometrically, you wouldn't even guess what it means to be a linear vector field. I mean, if you try, you may guess what it is that you would consider linear, but actually this vector field is linear. And that can be quite a surprising thing. So geometrically it's not easy to identify linear vector fields, but algebraically, if you remember that a vector field is an assignment of a vector to every point xy. So what you have to identify is the first coordinate of the vector, say p of xy, and the second q of xy. So the vector field is determined by two functions. Each of them is a function of two variables. And then what does it mean to be linear? It means that the function p is linear and the function q is linear. That's all it means. So linear vector field means linear functions used for the coordinates. And then one should think about what it means, what kind of constants are involved, and what the meanings are of those constants. And then quickly study all the vector fields, all the linear vector fields. And then among those vector fields, it is still a non-trivial question. Which linear vector field is conservative? Because as I told you, this vector field is linear, and we know it's not conservative. Although many other linear vector fields are conservative. So the plan for the future would be to look at all the linear vector fields to identify clearly what are those conservative and what are those not conservative. And, well, speaking the standard language used in calculus textbooks, those vector fields having curl are not conservative. And those vector fields having no curl are conservative. So basically this is the presence of curl, the presence of rotation in the vector field. If you see any rotation in the vector field, it doesn't satisfy the conservation law. For the simple reason that if you follow that rotation, your function increases all the time and the vector field cannot be a gradient. So basically the presence of rotation identifies whether the vector field is conservative or not. And then you step up to the linearizable and you generalize what you found there in terms of that curl statement, but unfortunately we will not have time to go there. I wish we had another week to study some linear vector fields and non-linear vector fields. What else? Well, that's basically the end of this story about vector field conservation of energy and possible plan for the future.